Good morning, students. This is Banu Prasad, working as Assistant Professor in the Department of Mechanical Engineering in MBR College of Engineering and Technology. Today we will discuss about Unit 2, Electrochemical Machining 1. So in our previous lecture, we will discuss about what is UCMP and define a non-traditional machining process and classifications of non-traditional machining process or unconventional machining process. What are the advantages, what are the disadvantages, what are the applications, so what are the future of unconventional machining process one. So next one is we will discuss our previous class one, ultrasonic machining process. Define ultrasonic machining process. What are the mechanisms you can use in ultrasonic machining process? Next one is what are the advantages, disadvantages, and applications of ultrasonic machining process. So it is our previous lecture. It is overall our first unit one. So it is basically introduction and ultrasonic machining process. Ultrasonic machining process is one of the mechanical energy machining process. So that is our overall first unit one. In the previous lecture, we will discuss the first unit one. First unit is completed. But today onwards, we will discuss about unit 2.1 electrochemical machining process. So see here, introduction of electrochemical machining process one. So electrochemical machining is electrochemical machining process ECM. So it is one of the newest and most useful non-traditional machining one. Non-traditional machining process belong to the electrochemical category. So it is one of the useful one and one of the useful method in the electrochemical category one. So electrochemical machining ECM is used to remove the material and alloys one which are difficult or impossible to machine by the mechanical machining process. So ECM is used to remove the material from an alloys one. And next one is difficult materials are impossible to machine by a mechanical machining process materials. It will be machined. It will be used to remove the metal from the workpiece. That is the main benefit for the electrochemical machining process. It is only used for alloys one from difficult materials, and conventional machining process cannot do that parts one. It can be used to remove here. So that is one of the benefit one. So the reverse of electroplating one. So next one is this machining process is based on Michael Faraday's classical law of electrolytics. So required basically two electrodes, an electrolyte, a gap, and a source of DC power of sufficient capacity. So it is in this process is ECM is basically depending on the Michael Faraday's classical law of electrolysis. Based on this principle one, they are doing the working process here. They are using the source of DC power supply. So it is one of the introduction of the electrochemical machining process. So see here, it is the diagram one, graph diagram of electrochemical machining process here. So it is a graphical diagram. So it is a, see here, it is a workpiece. This is a workpiece one. This is a insulating coating. So it is a tool one. This is tool. This tool outside one we have the insulating coating here. Both sides we can see. It is a tank one. It is electrolyte one. So it is a DC power supply. So it is a pump for circulating electrolyte. So it is positive ion. It is a negative ion. Positive cathode and anode one. Cathode anode one. So what is the working of this electrochemical machining means? So the tool onwards it is passing the power supply. Power supply based onwards the tool is moving from workpiece one. Automatically the required material is removed here. This is the working of the electrolytic electrochemical machining process. So it is one of the very easiest process one. Based on this tool onwards we are remove the material. How the tool is moving means here based on the power supply. The power supply onwards it is moving forward and backward one. After that only the required material it will be removing one. Finally we can get the required shape of the metal one. So this one we can call as the electrochemical machining process. So other things is the power supply is the main one here. It is a tool one here. It is a tank, electrolyte. This one it is a workpiece one. These are the major parts of the electrolyte machining process. So we'll see here another one. So see here, it is electrochemical machining process. This one. So same diagram one is the electrolyte workpiece, insulating coating tool. So it is a DC power supply, positive and negative ions. It is a pump one. Pump is circulating here. Pump for circulating electrolyte. Why it will be circulating means the smoothness of the cutting process. So machine should it is circulating one, electrolyte one. So non-traditional machining process of removing the metal from the extremely hard materials using a high current between the electrolyte tool piece and the workpiece one. So it is used for high current, high current onwards. Using high current onwards, we are removing the metal from the workpiece. First of all, first point that one. What is the second point? Means hard materials, hard and brittle materials are used to remove the metal from the electrochemical machining process. So electrochemical machining process are used for hard materials. Hard materials is nothing but here brittleness materials are used to remove the material from the electrochemical machining process. That is the major point here. Which kind of material we are used in the electrochemical machining process means brittleness material and high hardened materials are used in the electrochemical machining process. So these in this process mainly power supply is the main one here based on the high power onwards. So we are used to high power, we are used to remove the material here. So next one is see here working of the ECM. Working of the ECM, the actual process of ECM. The cathode tool is shaped mirror image of workpiece one, and the anode is the workpiece one. So the cathode is nothing but here mirror image of the workpiece one. The anode is the workpiece one. So a gap. So here we have the gap between. So the gap 0.05 to 0.7 is provided between the tool and the workpiece one. So in this one we can see the gap amount. Tool and the workpiece we have the gap. The gap is how much means 0.05 to 0.7 is provided the tool and the workpiece one. And the electrolyte flows through the gap at a velocity of 30 to 60 minutes and it completes the electrical circuit. So in this gap one machine should the electrolyte is floating the velocity of 30 to 60 meter per second and completely it is one of the electrical circuit one. So the electrolyte is pumped at a high pressure of 20 kgf per centimeter square 1.96 megapascal to the gap one. So electrolyte is passed the pressure of 20, see here 20 kgf per centimeter square 1.96 megapascal to the gap one. So next one is electrolyte must be circulated at a rate of sufficiently high to conduct current, between them and to carry the heat one. The electrolyte machine should pass this tool one. Why? Because the current will be supplied here. After then only the tool will move the workpiece and cut the workpiece one. So the metal is removed from the workpiece by the dissolution. So here after then when the power is applied to the tool one, automatically the tool will move for workpiece one. After then slowly it cut the workpiece one. So it is the working of the ECM. So see here, and the electrochemical machining process uses an electrolyte and electrical current to ionize and remove the metal atoms. So we can machine complex cavities and a high strength material. So the electrochemical machining process can be machined by high strength materials. So next one is leaves bar free surfaces one. So not affected by the strength, hardness and toughness of the material. So in this machining process, when the machining the material one, so it is not affected by the material one. Why? Because the strength will not be decreasing here, the toughness also not decreasing here. So that is the main advantages for the electrochemical machining process here. When we are machining the workpiece one, the properties cannot be changed here. That is the main one of the important point. So next one is see here elements of ECM. What are the major key elements we are used in the ECM means? So here 4 important points here. The first one is electrolyte. Next one is tool. Next one is workpiece. Next one is DC power supply. So electrolyte is common one. So here tool we are marking as cathode one. So next one is workpiece we are choosing as anode one. Next one is DC power supply. These four are the major key element for the ECM one. The first one is we will discuss here electrolyte. The common electrolyte used as sodium chloride, sodium nitrate, sodium hydroxide, sodium fluoride, sodium chloride, phosphanium chloride, and sulfuric acid. These solutions on reactions produce an insoluble compound in the form of the sludge one. So these solutions to take the reactions and produce an insoluble compound. Insoluble compound it will be producing one. So that's why we are using here electrolyte, some of the chemicals here. So next one is tool one. Tool one, cathode one. The most commonly used tool material are copper, brass, titanium, copper, tungsten, and stainless steel. And electrolyte is made of salts of sodium and potassium one.